Okay, example 3, section 2.2. Let's do some factorial examples now, where we're just looking for a final answer. So the first one here is pretty easy. You can just punch 7 factorial directly into your calculator. Or if you can't do that, we can do, you can certainly do this in your calculator, 7 times 6 times 5, like that. You don't need to write that out every time. But either way, it's 5,040. Oops, sorry, not 46, 5,040. Okay, let's look at the next example. So this is kind of why we talked about the formula in the last video. Because if we write out 9 factorial, you can, of course, do 9 factorial and then divide that by 6 factorial on your calculator. And that should still work. But the problem with factorials is you'll quickly find that your calculator is not going to be able to handle the sizes that the numbers will get up to. Certainly in example D there, you can't enter those into your calculator. But let's write out for a second in this example 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So there's 9 factorial. Okay, that's divided by 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. And now do you see that we have a lot of numbers in our numerator that are also in our denominator? And you should remember that whenever that happens, we can just start canceling things out. So in fact, 9 factorial divided by 6 factorial, when we write it out and simplify it, we're just left with 9 times 8 times 7, and everything else cancels. That's equal to 504. So, and we know we're allowed to do that from our formula that we just did. Kind of gives us that idea that we can write out any factorial n as n times n minus 1, etc. So we could also write this as n times, 9 times 8 times 7 times 6 factorial, write it over 6 factorial, and then cancel those there, which just gives us the same 9 times 8 times 7, which is 504. So whenever you see factorials and fractions like this, ask yourself what can cancel. Okay, for fractions. So in this next example here, C, where we have 12 factorial divided by 9 factorial times 3 factorial. Well, let's write out 12 factorial as 12 times 11 times 10, and then we'll stop at 9 factorial because we have one of those in our new denominator. And we can just cancel out those 2 factorials there. We'll leave the 3 factorial in because, yes, there is a 3 factorial that we could get out of if we keep writing out our 12 factorial. But we're already going to cancel out the 3 times 2 times 1 when we do the 9 factorial. So hopefully see that you can only cancel out things once, right? There needs to be something to cancel it with on top. So this one is left with 12 times 11 times 10, all divided by 3 factorial, which is 3 times 2. Or you can just punch in 3 factorial into your calculator, and that'll get you, so 1320 divided by 6 is equal to 220. Right, so we always want to start with breaking up the largest factorial in our problem and canceling from there. So with that, and I'll write that down, start with the largest factorial. So for example D here, 100 factorial over 97 factorial, you definitely cannot do this on your calculator. These numbers are way too big. but we know we can write 100 out as 100 times 99 times 98 times 97 factorial divided by 97 factorial. There's what can be cancelled, so we're just left with 100 multiplied by 99 multiplied by 98, and that is doable on a calculator. Still get a bit large number as the answer, but it's much more doable, and that'll give us 970,200.